everyone. My name is Sara Abbaspour. It's great to virtually join you at the International Conference of Security, Privacy, and Trust Management. I am researcher and associated senior lecturer at lardalen University, Sweden. I wish I could be there in person, but due to personal circumstances, I'm presenting remotely today. It's currently, let's see, 4 o'clock in the morning here. So finger crossed I won't doze off before wrapping up. Today, I'll be sharing our ongoing study, which is a short paper titled "A Systematic Approach Towards Enhancing Digital Privacy in Industrial Approach." Let's dive into it.
I think you went on mute.
Yeah. This is the outline. First I explained about the introduction, and then the overview of our methodology, and then I will talk about threats and attacks, privacy-related threats and attack. Then I will briefly explain about our case study or an example, which is about automated train control system, and finally I will conclude and explain about future work. When we discuss digital privacy, it's essential to also consider cybersecurity. Cybersecurity is the protection of the items which value we call assets of like a computer or a computer system. We can divide them into hardware, software, and data assets. In general, we can say the hardware assets can be our computer network and devices such as memory, printer, or cell phone, and so on. The software assets can be our operating system, commercial application like Microsoft Office, or photo editing in the individual application, and so on. And the data assets can be design of our new product, the photos of our recent vacation, the chapters of our new book, or music, videos, emails, and so on. The goal of cybersecurity is protecting our valuable assets. Digital privacy involves safeguarding online information such as personal details, industrial data, and sensitive information. In our interconnected world, ensuring digital privacy is important to protect against malicious actors and cyber attacks. The consequence of neglecting digital privacy can be identity theft. Personal information can be stolen and misused. Financial fraud, unauthorized access can be lead to significant financial losses, or violation of privacy rights, attacks on personal privacy and legal rights. Let's see some statistics about the some attack. According to the IBM X-Force report, it's the average cost of the data breach increased to $4.45 million in 2023. To address privacy in industrial application, we must focus on several key areas: protecting sensitive data, ensuring that sensitive data is secure, protected from unauthorized access, regulatory compliance, assisting companies in adhering to data protecting regulations like the General Data Protection Regulation, GDPR, and building trust, establishing and maintaining trust with customers and users by demonstrating commitment to data privacy and security. Now let's dive into our approach for this study. This slide gives you a quick overview of all steps, and in the next slide, I'll break down each step in detail. We have the system designer, which can give us the system specification or requirements of the system. Then in the step one, we make data flow diagram, and then the next step, we apply the sterã framework with the, on the DFD. And then we have threat list. We investigate privacy-related threats, and with this threat list, we can identify attack vectors, and by attack information, we can create attack scenarios, and then give those scenarios to the system tester and make him or her happy to do the test of the system. Step one, making a data flow diagram. DFD shows how data moves through our system. It has 5 elements. Process. These are tasks that take in data or something with it and give out a result. Data stores both temporary and permanent data for the system. External entity, this is stuff like third-party apps or system that interact with ours. Data flow shows how data moves between processes, data stores, and external entities. And the trust boundary, this is where data goes from one security level to another in our system. Up to this step, we have DFD, and in this step, we apply the sterã framework. sterã, introduced by Microsoft, and is a framework that breaks down security threats into 6 main categories: spoofing, tampering, reputation, information disclosure, denial of service, and evaluation of privilege. We map the elements of our DFD with introduced threats by sterã. For example, for all external entities, we will have spoofing and reputation threats, or for the process, we will have all threats introduced by sterã, and so on for other elements. Then we run a Microsoft threat modeling tool, and we can have a threat list as a result. In step 3, it's for investigating privacy-related threats. Here we are looking at privacy threats, which are like potential privacy attacks on our apps. We've been diving deep into the threat report, examining each type of threat, the description, to figure out how each one could affect us in terms of data privacy. This table reveals the finding from our research. We are identifying 5 potential effects, which we call attacks: data flow sniffing, data breach, unauthorized access, prevent access to the data store, and impersonate. Now let's break down each one with definition and some examples. Data flow sniffing attack is when someone intercept and monitor data moving between different parts of the system to steal sensitive information. Attackers can grab things like passwords or personal data just by listening on data transmissions. For example, an attacker might snag someone's login detail and use them to break into their account, getting access to all sort of private information. Data breach attack. This is when someone gets into sensitive stuff like personal data or financial records without permission. It splits the beans on private info to people who shouldn't have it, and they can mess with privacy and open the door to identify theft or other sneaky stuff. For example, imagine a retail site accidentally leak customer data. Attacker should steal credit card details. The attacker can steal credit card details and either use them or steal them to bad guys. Unauthorized access attack. This is when someone sneaks into a system, network, or a device without proper authorization. It lets attacker pick at, steal, or mess with sensitive information, breaking digital privacy and trust. For example, if someone hacks into a company's database, they might see customer records and other secret stuff which they shouldn't. The prevent access to the data store attack. This attack disrupts or block access to crucial data storage in a system or network. It typically shows the operation and slow the operation, or also it can slow the decision making. It doesn't directly expose personal information like addressing or something like credit card numbers. For instance, if a company denies access to customer record, it could disrupt customer service or data analysis effort, but it won't compromise sensitive details like address, phone numbers, or credit card information. The next one is impersonation attack. This is when someone unauthorized pretend to be a legit user or device to get into a system or network. By posing as a trusted entity, attackers can get hold of sensitive information or do things that breach privacy, like snooping on confidential data or tweaking system setting. For example, think of attacker sending a phishing email pretending to be from a company's HR team, asking an employee for sensitive information. The next step is identify attack vector. Here, up to here, we have DFD, and we found the effect or potential attacks. And then in this step, we will find the source and destination of the data flow, and we can make the attack vector. This is some example of one DFD. And the next one, we can merge these vectors to make attack scenarios. And after this, we can give this attack vector to the tester. The tester can make test cases or attack scenarios to the tester, and the tester can make test scenarios based on this information and the type of attack. As I explained, this study is a ongoing study, and we still didn't finish it yet, but we plan to have to apply our approach in this automated brake train control system. This is a DFD for this system, and system components and data flow of automated brake train control system are the controller is like the brain of our system in the DFD diagram. It's the main hub that coordinates everything. It gets input from sensors, the train driver, and the external sources, crushes the data, and then send out commands to the actuator. It also keeps the train driver updated on the brake status. The speed sensor is an external entity in our DFT diagram that tracks how fast the train is going. The proximity sensor is another external entity in our DFT diagram. It checks for obstacle or other train nearby. The braking system is a crucial process in our DFT diagram. It's the muscle that actually applies or releases the brakes based on what the controller tells it. After each command, it lets the controller know the current brake status. The train driver is the human operator and another external entity in our DFT diagram. It handles manual control and decision making for the train. The driver gives manual inputs to the controller to keep it in the loop. The controller updates the driver on the brake status so it can make decision if needed. We will apply our methodology in this DFT diagram, but still we don't have the result. As a summary up to here, I explained about our methodology. I explained about the threat and the potential attacks related to the privacy, and how we identify attack vectors and attack scenarios. And also I explained the automated train control system. The key takeaways, we can arm tester with attack scenarios to conduct security checkers during software development. By focusing on our scenarios, we can pinpoint threats to user privacy and enhance testing efforts. Through testing, help uncover vulnerabilities and promote potential attacks before they become real risk. Our insight can empower developers, security experts, and industries to bolster the privacy and security of their system and application. And as a future plan, we will apply our approach to the case study and dive into the results. We aim to automate the process and collaborate closely with system tester to generate test scenarios automatically. And we are excited about expanding into more industry for large scale testing and developing our approach in real world settings. So it was my talk, and thank you for your attention, and I'm happy to answer your question if there is any.